Hi everyone, this is Duke with a video here on how to build your WeTiny Freestyler in the FPV class, fall of 2024. So I'm making this video to update my instructions. We have different electronics this time than last time, and I also had written instructions last time, and I thought I'd make a video. So this is meant to help you assemble your quadcopter physically, and I have another video I made previously for setting up the software with Betaflight. So we're using Ryan Rogers' WeTiny Freestyler frame, which is a 3-inch frame. Works really well. I've really liked it the past 3 or 4 semesters we've taught this class, and it seems very durable, easy layout. I like the frame. Plus, I think it's really cool because Ryan is a local guy here, and it's kind of cool to have something designed by someone locally. So what we want to do here in this video is I'm going to start with some kind of notes for you because Ryan has a great video where he assembles the frame, and you can use his video to put this together. But there's a couple of things in his video that are more open because he has his frame set up in a way that's configurable for a variety of electronics. I'm going to address those things right now because we already know our specific electronics we're using. Okay, so that when you're going through his video, you go, oh yeah, Duke said to do it this way out of the options that Ryan has available. Okay, so I'll do a few notes here. I'll send you over to Ryan's video, and then you'll come back here to finish the electronics with me, if that makes sense. Okay, so the first thing I want to point out to you is the screws here. Okay, let's zoom in a little bit. All right, so these 4 screws that are sticking up through the bottom of the frame. Now Ryan has his frame set up so you can do different layouts. Okay, there are holes for 30 by 30 mounting. There's 20 by 20, which is where the screws are at, and there's 16 by 16. Those numbers refer to the distance between each hole. Okay, there's also 25.5 by 25.5 at a 45 degree to the others because that would be like an all-in-one or whoop type flight control board. Okay, so we're going to use a 20 by 20. Okay, so just realize when you're putting the screws into the bottom plate, as he talks about in the video, you want to put them in the 20 by 20 holes. Okay. Another thing that is specific to our build is that we're going to use screws that are 20 millimeters long, okay, by default. Those will come in your SpeedyB electronics. So in here, let's see, under the accessories area, we have the M3 category of parts there. And where did I put the M2 is over here, sorry. Took that out earlier. And the M2 section here. And we're not using M3, you can save that for another project or something. But the M2 is what we're going to use. There are 2 sets of long screws in here. One of them are 20 millimeters long and one other set is 25 millimeters long. The 20 millimeter long screws work great with our kind of standard class build. If you're going to add an HD FPV system like Walksnail or DJI or something like that, you're going to have to make some changes to the standard build, which may mean you want to use the 25 millimeter long screws, or even longer potentially, depending on your setup. Okay, there's not a lot of lateral space to grow things on the quad, so everything kind of has to go in the middle. And so if you have a different video transmitter, like a digital one compared to our analog that we're using in class, you may need to just make the quad taller, essentially, to fit everything in there. And you might want to consider using the 25 millimeter screws. Okay, 25 millimeter screws will fit with the rest of the standard build. Okay, this pink thing here is called a standoff, and that basically determines the height the top plate is from the bottom plate. Okay, so with the stock standoffs, which are these black ones, let's see where they go. Yours aren't pink, but they're black. Same thing though. Okay, with those stock ones, the longer screws will fit. But if you go over 25 millimeters in length of the screw, you'll have to buy different standoffs that are actually taller than the stock ones. Okay, so that's one note. You're going to use those screws when you install them into the bottom plate, which Ryan does in his video. Okay, the other kind of companion to this is how we install them. Okay, I don't recall, I haven't watched Ryan's video recently, I don't recall if he does this or not, but you can see I have the screws going up through the bottom plate, and I have a nut right here holding the screws so they're not just kind of flopping around in the plate. They're tightened down. Okay, sometimes that's called the golden nut. It's just a nut that's installed to keep the screws nice and rigid, helps with a lot of vibrations and things on the quad, makes it basically fly better overall. People do sometimes omit that nut, they don't put it in, and they just use the nut that goes on top of all the electronics to kind of sandwich everything together. That generally leads to poorer flight performance, so I'm having you all put the nuts on the screws on the bottom. Okay. We will also use metal M2 nuts in class. The M2 set here comes with some plastic ones. I don't really like those, so I'm having you guys use metal ones. Okay, so these are all metal M2 nuts here. All right. And that leads us into the discussion on how we attach screws and stuff to the quad. Ryan does not use Loctite in his video, and that's everyone can kind of choose, but in class I would like you guys to use Loctite on all of your hardware. All right. So when you're putting this nut onto the screw, as you thread it down a little bit, you want to thread it, 3/4 of the way or so. Get your Loctite out, put a little bit of Loctite on the threads, and then finish tightening the nut down so it goes through the Loctite and get some Loctite on its threads to tighten it down and keep it from coming loose. That would be a huge pain if it came loose. You have to take the X piece off at a minimum, which means the arms are kind of going to come off typically. Well, not all the way, but you got to take the X piece off at a minimum to get to the back side of these screws if you needed to tighten something down again. So you want to Loctite those. Also, other screws that you assemble for the frame, you should Loctite. Okay. Now, you want to build the frame basically to this point. You don't need to put the top plate on and stuff yet because we haven't done electronics. You want to build the frame to this point following Ryan's video, okay? And then you'll come back and I'll talk about electronics in a minute. But anything you assemble in this bottom section here should be Loctited, okay? As an example, how to Loctite a typical screw, okay? One that just goes straight into the frame, okay? A little bit different than the nuts up here. I'll show you. We'll just grab our screw. Grab some Loctite. Okay, this is the blue Loctite removable type. We're going to just apply a little bit of Loctite to the end of the thread of the screw, the part that's going to be into the frame press nut. Stuff comes out pretty fast. I'm trying to get it all over the table. Yeah, that's a little bit too much even, but see that little bit there? I'm going to wipe some of it off with my finger. I don't need that much. Okay, then I'll go ahead and put it back into the frame. Okay. You notice I already have the frame assembled, and now I'm putting Loctite on stuff and putting it back in. Whenever you're doing that, I find it easiest to assemble something first, especially with these arms, so they're held in place, and then I just pull one screw out, put Loctite on it, put it back in. Pull it out, Loctite, back in. Go around the circle there. It just helps, I think, to do that because then it's not trying to hold everything and keep it in place with your hands in, put the Loctite on and screw it in without getting Loctite all over the place and getting frustrated. So those are some of the notes I have as far as the frame assembly. So I think that's it. We'll do the electronics, like I said, when you come back from watching Ryan's video. But this is the general rule. Remember, 20 by 20 mounting pattern, 20 millimeter long screws if you're going to do the standard build. Okay, and don't forget the Loctite. All right. So at this point, you want to pause the video, go watch Ryan's frame assembly video, and then come back and finish this up. All right. So now you're back from assembling the frame with Ryan's video, and we're going to talk about electronics and how they physically attach to the aircraft and everything. So we'll start kind of in the middle here with the stack, right? And your SpeedyB stack comes like this, as you've probably already seen. You have two components here, okay? Your ESC, or your electronic speed controller, and your flight controller, or also known as your FC. Okay? These are going to go on these 4 screws. Okay? And I'm going to assemble everything here, kind of modeling how you would solder it. I'm not going to do any soldering right now. I need to save these components for another build. Okay? But I'm going to kind of model it out here for you so you can see where you're going to attach things. Okay? So this yellow part here being the front of the drone, here's our electronic speed controller mounted there. You can see that with those little gummies, it doesn't touch the carbon or anything. Carbon is conductive, so that's good. It's not touching. And this is basically the power distribution of our aircraft. Battery power is going to come in the back here, and it's going to be distributed to the 4 motors. And that's how our drone is going to fly, essentially, in terms of power. The other component here is the flight controller. This will go right on top of the ESC. Okay, and this is why they call it a stack. We're stacking the things on top of each other. We get this onto the screws, so it's finicky. There we go. And so we'll see our stack's going to look like that. There we go. Okay. And so that's where the 2 components will go. We obviously need to do some wiring, but this is where they'll be located. And with those 20 millimeter screws, there's enough thread here to grab another nut and put it right on top and compress the stack a little bit. That'll be just about perfect to hold everything together. And that will allow us to have plenty of space. We don't need the screws to be longer than that. unless you're doing something else where you need to stack another component on top of these. Okay, the standard class build we will not need that. So let's take the flight controller back off for a second. Okay, with your SpeedyB kit as well, you also receive a little bag of goodies like this. Okay, it's in the bottom of the box under the accessories tab. Okay. You have some different harnesses here. This longer harness you won't need. We don't use that for anything in class. So you just leave that in the bag, whatever you want to do with it. We will use, though, these other three components. And as you can see, I've been fiddling around the capacitor already. It's usually not that bent, but that's okay. So we have a battery lead, a capacitor, and a wiring harness that goes between our flight controller and our ESC. These need to be connected in order for the flight controller, the brains of the operation, to give the ESC signals to tell it how fast to spin the motors and which motor to spin. Okay. So let's start with this one though. Actually with the capacitor probably. We'll start with the capacitor. So the capacitor goes here on the back on the battery terminals. We talked about it in class a little bit, but capacitors help smooth out voltage so there's no big spikes, or at least not as big of spikes that damage components from our battery. And so that's what this is for. We're going to zoom a little bit more here. You can see on the capacitor we have a negative side, which is also the shorter of the two legs. Okay, we want to make sure we put that in the right section on our ESC, the right pad here. So they have those nice little holes already kind of pre-installed for us on these two battery pads. Do this a couple ways. You can bring the capacitor in rather close and just bend it over like so. Okay, and solder that on. Okay, make sure you solder those in place, and then trim the extra excess off the bottom so it's nice and flat or flush. Okay, or alternatively, if you don't want to have the capacitor sticking right there, right back in the center like that, you can make the leads a little bit longer. I'm going to bend this back here, and you kind of bring it off to the side. Okay, the idea being, if I can get this back on here, it's always a battle to get these holes lined up for some reason. There we go. The idea being here, if we bring it off to the side and bend those under a little bit. Okay, again, you'd trim those bottom ones off after you soldered it. We kind of measure it out here so that we would have a way to keep the capacitor off to the side. Sorry, keep the capacitor off to the side. Run a zip tie around the capacitor and kind of hold it in place so it's not vibrating or causing any excess noise, electrical noise or anything like that on the aircraft. Oh, I messed up the gummy. Whoops. That's my bad. Didn't actually get it through there on that one. There we go. That's better. Okay. So you can bring it back and strap it on here. And sorry, not electrical noise, but any other vibrational noise on the aircraft. You could zip tie that down and have those leads be a little bit longer. Okay. The trade-off here is basically comes when we install our other component onto the battery leads here, which is the pigtail itself, the battery pigtail where you're going to plug your battery into later. Okay, this gets installed into the TPU mount here that goes in the back of the drone. So you can see on this one, the battery plug is right there, the video transmitter antenna is right there. This is installed in the back of the drone by putting the screws and standoffs through it. Okay, so we'll eventually get to that. When you're building the frame, you'll see that part as well. But we want to make sure we thread this through first. Okay. It is directional, so the 3D print has a curved side and a flat side, just like the actual connector itself does. Okay, so we'll thread that through there. That's meant to kind of suck in and push in there a little bit. I'm just going to leave a little bit of it hanging out so I can remove it again later since I got to take this back apart. But like so, okay. This is going to be mounted roughly about here where those back two holes are. Okay. And so if you put the capacitor off to the side, you may find it a little bit easier to run your cables up to the battery pads here from the connector, just kind of straight in. If that makes sense. You need to trim these; they're going to be too long, anyways. But you can run it more straight in. Okay. Whereas if the capacitor is in the center, like we had it earlier, okay, it's going to effectively block some of the ability for you to put the battery cables straight in. Yeah, you're going to have to kind of go around the capacitor somehow. And you do have to reverse these. Unfortunately, this direction of the connector forces it to be negative on the left and positive on the right. but the ESC has negative on the right and positive on the left. So just make sure you look at the signs there, plus and minus. You got to cross these over though. Okay. And then you're going to go ahead and attach them like going around the capacitor like so, or something like that, to that effect. Okay. You might have to do something like that if you have the capacitor coming straight out. It's up to you. And honestly, you could also, if you really wanted to, mount the ESC upside down. Okay. And then have the battery leads come straight kind of that way over the ESC. There are a number of different configurations you can use, but I'm trying to explain a few of them so you can get a feel for what you're going for here and make your decision on how you want to route things. Okay, so that's our capacitor attached there, whether it's short or a little bit longer off to the side. And then we need to attach our battery lead, like I mentioned. You need to cut this down to a shorter length, tin the wires and tin the pads and everything and attach it there. And that will give us basically our battery power into our ESC. Okay. The next step of our powertrain is the motor's attachment to the ESC. Okay. You can see I have one motor attached here already. So let's take a look at how we did that. Okay. With our motor, it gets attached to the arm. You can see the holes here. There's 4 holes for the screws and 1 hole in the center for the motor shaft. It kind of protrudes a little bit. And we'll take this one off. Okay, there's that protrusion on the bottom there that sticks in that center hole. Okay. So we'll do that. Attach the motor like so to the arm along with this yellow bumper thing. Now some of you may have the arm kind of skid protectors that go on the edge out here. I'm not using those in the video because not all the kits have those. It depends on which prints we got and that kind of thing. But if you have those, you can obviously slip those over the arm as well and put the yellow thing on top of those. Okay, which is kind of how this one is set up. We have the yellow skid, the TPU kind of protective piece here, and then the carbon. A student printed these out for me a couple years ago when we were doing that build, so that's why they're on there. Okay. But an important part about attaching the motors is which screws you use. Okay. And in the video, the frame video, Ryan mentions that the M2x6 screws are for the motors. It varies motor to motor and things like that. And M2x6 screws, in my opinion, are a little bit too long. They go up too far into the motor, get too close to the copper coils in there, which will damage the motor. Okay, with these particular motors. Not all motors are the same, right? But with these motors and the thickness of this attachment plate right here, M2x6s are too long, so we can't use those for these motors. Luckily, however, the motors you have ship with 5, which is kind of crazy, 5 different sizes of screws for use with the motors and the propellers. Okay, and I went through and measured these, and we have some M2x4s, M2x5, M2x6. Okay, and so what works really well is instead of using the M2x6s, whether it's from the motor kit or the frame kit, is actually if you use the M2x5s. They're a little bit shorter and they work really well. Okay, let's get these back up. So grab the M2x5s, which will be the second to smallest bag of screws in each motor package. Okay. Grab one of those. All right. And take the yellow piece here. This is how I double check motor screw length, basically. I'll put the screw on here. Run it through all the stuff I'm going to run it through. So in this case, the skid plate and the carbon arm. We can see how far it sticks out there. Right now, it's going to be hard to see on camera, but if you then take your motor and just lay it over the edge, okay, without getting the shaft in the way, the motor shaft in the way, okay, you can kind of begin, let's see if we can zoom in and get any better. There we go. You can begin to see maybe what I'm doing here. I'm just trying to see how far, as I screw this in, how far is it going to stick out, and how far do I want it to stick out to get through that motor plate. So you can see as we put those next to each other, they're essentially the same height, almost exactly. And to me, that's just about perfect. It doesn't go too far into the motor. We know it's going far enough because it's just about the same height as the motor mount piece. Okay, so I'm going to use M2x5 screws to mount my motors. When you mount the motors, you want to make sure that the shaft again is in that center hole, and then the 4 screw holes line up, and your motor wires should travel back in the direction along the arm. They shouldn't stick out, a different way. So let's go ahead and put this together. And kind of get it snug enough it's not going to fall off. You don't need to tighten it down all the way yet because we've got to line up the other 4 screws as well. So we'll make sure that's getting to be nice and flush. We're not stuck on the motor shaft not being in the hole or something. And we have 1 screw in, so we'll make sure the other ones get lined up with both the plastic piece and the carbon and the motor, and then we'll put the other 3 screws in. Then again, you want to take them out one by one and put Loctite on each screw and put it back in so the motor is Loctited in place. These, there's vibrations on quadcopters all the time, and if you don't put Loctite on these, in my opinion, there's a pretty good chance that they'll loosen up during flight. And in my last semester teaching this class, we actually had a student who didn't put Loctite on, and the motor nearly fell off after a few flights. And he didn't, barely noticed in time, basically, before the motor came off. So I'm not saying that'll happen to everyone, but in my opinion, you should use Loctite on motor screws. So we'll do that and attach the motor that way. Okay. Once you have a motor attached, then you, of course, go and do the other 3, right? Same way. And we have our motor wires, which are plenty long, which is nice. We don't have to worry about lengthening wires, which is kind of a pain. They're plenty long. Each motor is going to need to reach to the ESC in its corresponding position. Okay. So there are 6 pads on each side, 6 solder pads, 3 for the back and 3 for the front. Okay. So your motor wires should reach along the arm, here, and not be pulled taut. You don't want the motor wires like that. It's too tight. Okay. Give yourself a little bit of slack, kind of run your finger along the wires, and then make sure they're going to be long enough when you cut them that you can attach them to the pads there. Maybe something like that in terms of length. You can put a zip tie around the arm to hold the wires in place so they don't get up in the air and get cut up by the propellers. Okay. But you don't need a ton of slack because that's really hard to manage and not get cut by the props. You don't want it to be too short because then it can cause problems with actually, damaging the wires, and also it's just hard to solder. Okay. So each motor will go into its corresponding position with the wires and be soldered in place. So here, 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 and here. And then your ESC and motors are soldered up and ready to go. Okay. So that takes care of basically the powertrain essentially of the quad. We have the battery lead back here. Okay. Let's scoot that up a little bit. Battery lead back here. The motors are attached to the ESC. It's all connected together. Okay. And that's great. With the next step here, we have the flight controller and ESC. Okay. And we notice we have this little plug on both of those. Okay. And we have this little harness that comes with our kit or our electronics. And this is meant to connect the flight controller to the ESC. Okay. When you're doing these plugs, make sure that you're not forcing anything. You should get the pins and the plug to line up with the ones on the flight controller ESC. It's going to be kind of on the top or on the bottom, right? The pins are not perfectly centered. They're offset. And if we look at both the flight controller and ESC, we can see on the side of the connectors, so on this side, let's see if we get that close enough. There's some small lettering or numbering here. We have a minus, plus, 1, 2, 3, 4, CN. The flight controller is labeled a little bit differently, but similar. Yeah. We have a GV12 and then a 3, 4, CT. Okay. Those are all different, basically abbreviations for what these wires are doing. Okay, so this should work out of the box. It's from the same manufacturer. They give it to us as a set, so it should work. But just in case, we can double check things by making sure if we plug it in the right way, making sure the pins are aligned. In this case, we're going to have the pins kind of towards the camera more. It should slide in, and then use your fingernails to kind of press it all the way in so it seats properly. Okay. And if we say, okay, let's look at that again, we have our minus, plus, 1, 2, and here we have black and then red. That's kind of the standard color for negative and then positive. So minus and then plus. So that's, generally speaking, it should be incorrectly, right? These other wires, of course, could be out of sorts or something, but they shouldn't be since it's from the manufacturer. But that wouldn't do any damage if we plugged it in backwards per se. If you had the positive and negative out of order or in a different spot, that could damage components permanently. So we don't want to make sure we don't do that. The other side of the stack has the same type of connector here, so we'll install that. Okay. It goes in this orientation per the pins. We can double check the orientation, okay, via those little numbers there and letters. So instead of saying plus minus, it has a G and then a V, so ground and then voltage or power. And then again, 1, 2, 3, 4. And we have a C and a T here, which correspond to the C on the ESC as well. So that is our stack wired together. Okay. When we put it on the drone, this will be on the bottom, this will be on the top. Okay. You can leave it like that. It does kind of stick out a bit. A lot of wires right there. You can kind of tuck it over to the side if you want. Or alternatively, you could try twisting it maybe once. Okay. Maybe I twist that twice. Let's see. No, just like that. There we go. Okay, so like a full 360. Get the wires in a little more of a bundle. You don't want to twist it too many times and damage the wires or put extra stress on them, but that helps keep it a little bit tidier, closer to the boards themselves, which is nice to give us more space on the frame. Okay, and there's our stack. Right. So let's bring the frame back over. So we're going to let this sit down here on our screws. There we go. And then we have our stack installed on the quad. Everything's got good clearance, not in the way or anything. Looks good. Okay. And we just give a little more space here so we can more easily fit our camera up in the front, perhaps. All right. So that is the stack and motor wiring. Okay. Next, we're going to kind of get the extra stuff with the camera, the video transmitter, the receiver, and we'll jump into that next. All right. So, well, the next few steps, I'm going to be going back and forth between the document camera and SpeedyB's website, which is where they have the product manual for this flight controller. You should also be able to get to it with the little QR code thing that comes with the electronics, so you can scan that or just find the website. Either way is fine. Let's turn that on real quick. Okay. I have the weird OBS thing so I can show you guys my mouse pointer. So if we go up to the top here, let's go back to regular size. So I'll show you where I'm at. Let's go back to SpeedyB. There we go. Okay, so SpeedyB's main website is here. They sell a number of different products, kind of all related to drones or cameras or things like that. Okay, let's make sure this is recording. Okay. But we're going to go here to Products, Stack, and then go to our 20 by 20 stack over here on the right hand side. F405 Mini BLS 20 by 20. Okay, click on that one. And that's the page I was just on before we went back. So if you scroll in here, they got a lot of pictures and stuff. I'm actually going to zoom out a little bit so we can find everything easier. Get down past all the pictures and stuff here. We get to some actual specifications and a wiring diagram. Okay. You want to reference this as you go through the build. I'm going to walk through it here with you, but I would recommend you reference it. You can even print it out. Sometimes it's nice to have a physical thing to look at when you're building so you don't have to go back and forth the computer a bunch of times. But here is a wiring diagram for the flight controller. Okay. You also see down here we have a wiring diagram for the flight controller to ESC, which we just did. That little harness we plugged in between the two boards is what we just did there. So that's there as well. And you can see the motor wiring here and the capacitor and the power cable here as well. So basically that's what we did already. And now we're going to focus on this last step here with the flight controller. Okay, this is a little more complex since they have multiple options you can connect. Okay, but in our class, and I think all of you are using an Express LRS receiver. Okay, so one up here in the upper right hand corner. And that's the first thing we're going to talk about wiring up is the receiver. Okay, so you'll need to supply your own receiver for the class. So you might have a different model than what I'm going to show you on camera, but Express LRS receivers of all types are pretty much wired the same in many ways. So we're going to just go with that generically. Okay. You'll see on the receiver here, it has 4 solder pads, is what these are representing here. RX, TX, 5 volt, and ground. Okay. Those 4 solder pads are going to be connected to wires, which will then connect to the flight controller. Okay. And if you follow the wires down, you'll see that they go right here to the upper right hand corner of the board where we have a ground or G, 4V5 or power. Then we have an R2 and a T2. Okay. So ground and 5 volts, or ground and power, just go straight down to ground and 4V5, which is almost 5 volts and turns on when you plug it in with USB. So that's nice to have our receiver power up on USB only, not just battery power. But those two wires will go down there, ground and 5 volt to the ground and 4v5 pads. Okay. The tricky part is not that tricky, but you got to make sure that you wire your TX on your receiver to the R2 or receive pad on the flight controller, and your receive or RX pad on the receiver goes down to the T2 or transmit pad on the flight controller. So we go TX to R and RX to T. Okay, and that's so that the flight controller and receiver can talk back and forth with each other on those two wires. One talks, the other receives. One talks, the other receives, and if that makes sense, vice versa. Okay. So if we go over to our actual flight controller, okay, this is hard to see on the dot cam, but up here in the front, so this is the front of the drone, we have our T2, R2, 4v5, and ground, those 4 pads right there, where we're going to attach our receiver. Okay, in this case, this receiver has it nicely labeled as well. We have a ground, 5 volt TX and RX, so we know where those go now on the flight controller. The last thing you want to think about is how long to make your wires. Okay. You don't always really want to have wires going right over the top of the flight controller if you can help it. So, I mean, you could do that, but you can also run the wires underneath the entire stack and have them come out the front and wrap around. Typically, at least when I built these, I have the receiver in the back here, and I zip tie it again in place on the other side here around this little loop. I zip tie the receiver in place. I have the wires go around, come up, and solder right here. You could mount the receiver in other positions as well. You could experiment and see where you like it best. But try to avoid having wires going directly over the flight controller or directly under it if you can at all help it. Okay, so those 4 wires will give you connection between your receiver and your flight controller and will also power your receiver. Okay. All right, next up is our camera. Okay, let's grab our camera out here. There we go. Okay. So the camera is a Caddx Ant. Comes in a box like this. Okay. It comes with a couple different cables. Comes with this little board, this little piece here, this green and black cable, and then the one I have plugged in here, this red, yellow, and black cable. Okay. Right now I have the camera attached to one of the standoffs, or one of the mounts for the front of the drone, so we'll talk about that in a second. But on the back of the camera, we have 5 different pins in 2 different plugs. So we have a 3-pin and a 2-pin on the right-hand side. The 2-pin is for this black and green cable and for this little joystick pad thing. Okay, you can use this to adjust camera settings in the terms of like white exposure and color saturation and stuff like that on the camera if you so choose to do so. I've never really messed with those on any camera that I've used. I don't have a ton of experience with different FPV cameras, but I've never needed to mess with those. If you do want to use them, you can, and this is how you would configure those once the camera is powered from the flight controller. But we're not going to fly with this installed, so we'll set it aside for now. We don't need this mount. This is to make the camera effectively larger. Okay, it just goes around the camera for mounting in a larger quadcopter, but we're not doing that, so we don't need that piece. All we really need is the camera, the cables, and then there's a handful of screws that come with the camera. Okay, oops, let me zoom out a little bit. That are used for attaching the camera to the drone. Okay, so you can see here what I've done is I actually took this whole standoff off the quadcopter, but you'll notice this yellow piece and this purple piece go in the front here. Now yours will be the same color, I just have different ones I'm testing. Okay, they'll go in the front here, and these pink standoffs get screwed into the frame. Okay, so they stay in place like the yellow one is right now. Your standoffs will be black. I just have different colored ones here. What we do to attach the camera to the drone is we're going to attach it physically using some of the screws that come with the camera. You just want to find a screw that has a good length. Okay, they can go through the 3D print and protrude a little bit, okay, which will allow it to screw right into the side of the camera where the screw holes are at right there. Okay, one on each side. You can mount that right now, or you can mount it after you do the wiring. Either way is fine, but just to show you how this works. Okay, I'm going to tighten the screw down. I'm going to kind of snug it down. I don't need to wrench on it, but get it nice and snug. And then once this is installed, okay, the other side will get screwed in as well. And so it'll kind of pinch the camera in between those two 3D printed pieces, which will keep it in place, both, not having it tilted left or right, but also keeping the camera at the angle in which you put it at. So it's not tilting up or down while you're flying. It should stay in a fixed position and just be able to see out from there, if that makes sense. Okay. You notice I use the front holes. There's a small hole in the back on the prints and then a larger kind of slot hole on the front. The front one works well, I found, and you don't get too much of the 3D printed stuff in your camera view, which is nice. You just see what's in front of the drone. You could move the camera back slightly if you wanted to, maybe get a little more protection from hitting stuff in the front of the quad, though I haven't had a problem with that. Okay, either hole works just fine. That's the physical mounting of the camera into those TPU 3D printed parts. And then we talk about the wiring. Okay, so we have this harness here with 3 wires. I'm going to tell you right now it's power, ground, and video signal. Okay, let's flip over to the diagram on the website and look at that. Okay, so zoom out here on our wiring diagram. We're going to zoom back in on this RunCam model Phoenix 2, which is a camera. Okay, you'll see it has 5 pins in the back, a group of 3 and a group of 2, just like our camera. And we can see the red, black, and yellow here. Okay, you can see this blue one as well. You can do some of those camera settings through your flight controller if you want to. You can wire it up that way like that blue wire is. I'm not going to worry about having you guys do that in class. I don't think it's super necessary, but you can do that if you'd like. That should allow you to control some of those camera specific settings from your flight controller. But what we're going to focus on is the red wire here going from the camera to 5 volts, the black wire going from ground to ground, and the video going from video to the cam pad. Okay. So in our instance here, look at our flight controller closely. Okay, we have top 5V, ground, and cam. So those 3 pads right there. Excuse me. The 3 ones we talked about, and the 3 wires come out of the harness, okay, to be cut to length and soldered onto the flight controller. Leave yourself a little bit of slack. It doesn't need to be tight. Again, nothing needs to be tight, but you don't need to like cut it way down here and have, that much slack. That's too much. You don't need that much. Okay, so attach those front 3 there, and that will wire up your camera to give it both power and allow a video signal to come from the camera into the flight controller. We'll talk about the second half of that signal next. Hi everybody, this is Duke from the future with a video addition to our video for the FPV class build. I need to update the video as we have a different VTX and we're adding a GPS this semester, which was not in the original video, and so I'm just kind of sticking this in the middle of this video, trying to make the edit a little bit smooth, but basically trying to get the facts across here. So in the other video, I was about to show you the video transmitter. That's what I'm going to show you here. Unfortunately, I don't have a mock-up of this entire system physically with me. I do have the video transmitter, but I don't have the flight controller and stuff already mounted onto a frame and everything, because I don't have any more of these flight controllers this semester. A little bit more scarce this semester than they have been in the past. And you're all using all of them in class, which is good. But I'm going to use the RTL draw page here to walk you through some of the wiring and then show you the physical video transmitter in correlation with the wiring here. So the other half, like I mentioned in the video, the other half of the video transmitter system, so we have the camera over here going into the flight controller, and from the flight controller goes out to the video transmitter in this case. And here's our video transmitter. This is a Rush Tank Race 2. And I have a picture of the front of it here, which we'll talk about in a second. But basically there are 5 possible pads on the back of this video transmitter for you to solder wires to. And we're going to use 4 of those pads. And you can see here they're attached to the flight controller with the corresponding colors. So we have 5 volt here in red going to 5 volt. Ground is in white going to ground. We have the video in yellow orangish color going to the VTX pad. And data going to T1. And if you reference the actual speed-to-beat diagram over here, it's very similar. We have 5 volt ground video going to the 5 volt pad, the ground pad, and yellow is video going to the VTX pad. And over here it says IRC, which is the IRC tramp. That's the protocol that this video transmitter uses. Ours uses smart audio, if I remember right, but it doesn't really matter either way. The blue wire here is going to go into the T1 pad, just like our data wire in green here is going to the T1 pad. All that is a wire that allows the flight controller to talk to the video transmitter and tell it to change channels and change power levels and stuff like that. So we need to attach to a T1, a transmit pin, to go to the data pad here. We don't use the ground pad on the video transmitter for anything, so that's just left unoccupied. Okay. With our video transmitter, the other portion of this, I guess, so from camera captures the video, feeds it through the flight controller, which overlays the on-screen display, and that video with the on-screen display is then sent to the video transmitter via this video wire here. After that, where does it go though is out the antenna basically. And so the other side of the video transmitter, which is pictured here, this is the same thing as this, just the front and back. There's this connector here on the top left-hand corner. It's like a little circle with a pin in the middle, kind of. That's called a UFL, or sometimes called an IPEX connector, depends on what it's used for, what size it is, and that kind of stuff. Oftentimes in FPV, you'll see it call it a UFL connector, though. And up here at the top, I have just an image I found online of an antenna with a UFL connector. So a video transmitter antenna. This is a right-hand circular polarized antenna. And we have a UFL connector on there. And so if you look at the connector, it's got kind of this outer ring here, and then the inner receptacle for the pin. So the outer ring is one contact, and the inner receptacle is the other contact. If you look here, we have the outer ring and then the inner pin. So you can kind of imagine this is going to snap right on top of this one here, kind of a click. I'll show you in the dot cam in a second. You need to be fairly careful with these connectors. They are more fragile than other things we deal with, and so it's pretty easy to break this crimp right here or bust the connector or things like that. So I'll show you in the dot cam in just a second how that works live. But there's our video transmitter antenna, and it's going to send the signals out through to our FPV goggles so we can see the video feed. So let's switch over for a second to, where is OBS? There, OBS. Switch over to our dot cam, and we'll zoom in a little bit here. Okay, so we have our video transmitter antenna. This is the 3D printed mount we're going to be using, and then we have our video transmitter itself. So let me widen this a little bit. Our video transmitter, just like you saw in the image, has the 5 pads on the back, and if we were to zoom back in, we would see the labels more or less. A little hard to see in the dot cam, but each of these pads has a different label: 5-volt ground, video, data, and ground. So those are our 5 solder pads. You can solder to the flat portion here, or you can solder to the castellated holes here. I'd recommend doing the flat pads since there's no reason to do the castellated pads in how we're setting this up. This will be, at some point, attached to the bottom side of our top plate. So our top plate of our quad looks like this. It's going to be attached, I know where the sticky stuff is right here, basically, like so, or like so, orientation wise. It'll be stuck there, and so in my opinion it works best to have the wires coming out flat from the VTX, not at a 90-degree angle like the castellated holes would have you do. Now speaking of that, when we orient this inside of our quad, here's just an example antenna. This is not the same antenna you might have, but it has a UFL connector. And you can kind of see that, and that's going to clip on right here onto the VTX. Okay, don't necessarily clip it on right this second, but just be aware that's where it goes. Okay, so if we think about this, the antenna is going to likely have to come off the back or the side like this, because this little rim here, this metal plate, is going to block it from really coming off this way or this way. It needs to seat down fully, and to do that it's going to have to come off over here to over here. You have about a 90-degree rotation of where it can come off. So if we're going to be having this come off and having these wires come off, it would be advantageous to make the wires long enough and run the wires in the same direction or completely the opposite direction as the antenna. So we don't want the wires coming out like the side or this side. We want the front or the back, and that's because that way we can put a piece of heat shrink over this entire thing before we attach it to the carbon fiber. Okay. So it's up to you if you want to have them come off the front or the back. If you have them come off the front, right, you're going to need to attach the heat shrink before you put the antenna on. Because you can't put the heat shrink probably, well, maybe you could. Maybe you could fit the heat shrink over the antenna and over the VTX. But if you think about this, you have wires coming out one side and the antenna coming out the other side. You got to put the heat shrink over before one of those two things goes on. If you put the wires coming out the same side as the antenna, roughly like so, once you're finished, you can just slide the heat shrink over the entire thing from one direction. But your wires will probably have to be a little bit longer to reach kind of that extra loop from the video transmitter all the way over to the flight controller. So up to you on how you want to do that. But I would advise you to have that come off, the wires come off either the front or the back, not like out the side kind of or anything like that. Okay. The way this connector works, see if I can kind of show you this on camera. And of course, I'm happy to help you with this in class. But you have this little UFL connector here. Okay. You can see it matches up. It's got the circle and the inner pin. When you're putting these on, you want to get it straight over the connector and then just push straight in and it will click on. I'm not going to do it right now because I don't want to have to take this off and possibly damage something, but the less cycles of on and off, the better. The tighter the connection will be, unless it'll pop off on accident. Basically going to get it lined up straight, push it straight on. If you have the connector on, you need to take it off for some reason. You're going to have the connector, installed, and then you want to basically try to get your fingernails around the edges of it so you can pull straight off. You don't want to like twist it or yank it or something. You just want to pop straight off with the connection in order to not damage anything. And make sure not to yank on the wire. Always try to grab the connector like with your fingernails or something like that. The crimp is fairly fragile and also very small, so it's easy to break this portion here. That's happened to a lot of people in the past. So there's our VTX, and this antenna here will get placed into the 3D printed mount here. This one's a little bit rough around the edges, trying to get the TPU settings right. But the antenna will go down through here, or through this cavity here, and you kind of come from one side or the other, doesn't really matter. Okay. All you want to do is press this in and stretch the TPU over the antenna. It should have a nice snug fit like that. And this end will come out down here. And you can kind of see on this aircraft, sort of. Let's see. Here's the teal antenna here. This thicker black cable, a little bit hard to see with contrast there. One right above my finger is coming down and out. It's going over to this. This is the VTX on this aircraft, but either way, you kind of see that thicker black one right there where my finger's at. It's going to come down and out. You can kind of see it coming down here through the back a little bit, down around, and then through to the VTX. So on our aircraft, this will be the back of the aircraft, going to come down, around, and then hook into the VTX inside the aircraft. And that's why you want to figure out how long your wires have to be for this to make sure they can reach the flight controller, because this is a fixed length. We can't really make this longer very easily. But the wires here, you can use these, or you can just get some wires from the lab that are longer, plenty of length to reach from your flight controller to the video transmitter with the wires. Okay. I hope that helps with the video transmitter setup there. And that completes our video system. So from the camera to the flight controller to the VTX to the antenna to our goggles. Okay, let's go back over here for a moment. So we have that explained there. It keeps making these little hand icons. I don't know where those come from. Interesting, but all right. The last thing I need to explain in this kind of interruption from the future is our GPS. We have not done this in the class in the past, so it's not in the older video. But essentially, you're going to follow the wiring diagram you made, which is part of the reason why you made it, and wire up the GPS to the flight controller. Just remember, whenever you're using what's called a UART, a TX and RX pair, in this case, they need to be swapped. So we have our TX in orange here going to R6. We have our RX in blue going to T6, and they need to be the same set. So these are both 6. That's the same set. We have our ground here in white going over to ground. 5 volt goes to 4V5, and that might seem kind of confusing because there's a 5 volt pad right over here. The difference is 4V5 pads will be powered up on USB power only, so they're actually more like, I think, 4.8 volts or something like that. And 5-volt pads are only powered up when you plug in the main battery that you're going to fly with. The advantage to this is that our GPS can be powered up with just USB power, and so we can maybe use a USB power bank or something and let it sit there and get a GPS fix while we're configuring things, or plugged into the computer while we're configuring things. But our video transmitter is on 5 volts, and video transmitters overheat quite easily. And so it's good to not have the video transmitter powered up while we're messing around with the configuration or waiting for a satellite fix for the GPS. We only have this powered up once we plug in the actual flight battery. So that's a good way to do it, to have the VTX on 5 volts and the GPS and our receiver actually as well on 4v5. Okay, you can see the 4v5 up here for our receiver. Same idea there. It can power up with just computer power, so we can set up our transmitter, configure our flight modes, and all that good stuff. But continuing on, we have 4v5, and then we have SCL, and here in purple going to the CL pad, and SDA going to the DA pad. So that's our GPS setup there in terms of wiring. If we go over to the dot cam, let's see, there we go. Let's swap this out for our GPS. You should have a GPS looks like this. It's a walk snail GPS. It comes with this little harness here, which is kind of nice. A little bit. You can see on the back of the walk snail GPS, we have those labels, TX, RX. I can read that. Ground, 5 volt, SCL, and SDA. And so as we look at those labels there, we go, okay, well, this is the order. And it comes with this nice harness. Okay. And you're going to plug one of these ends into the GPS. So let's take a look here. Typically red and black are power and ground, kind of standardized there. So if red is the 4th wire here from the left, 1, 2, 3, 4, we could give a good guess that we plug it in this direction, but we're going to check the pins. And so we can see here, if you can see, the pins are on the top side of the connector. So they're kind of more up where the screwdriver's at on that side rather than down by the board. And in here, the pin receptacles are on the top side, well, the bottom in the photograph, but on the bottom side here of this. So if we plug this in, they're going to match up. Okay, now they're both on the top. So we're going to plug it in like this, and we're going to make sure it's nice and seated. You can use your fingernails to kind of press it in there, make sure it's seated well. Okay, and there's your GPS plugged in. Now, I should have shown you in a different order because you don't necessarily need to plug it in before you install it into the 3D printed mount. However, for continuation here, we have it plugged in, and then the other end here, we will snip off, and we will direct solder these wires to the flight controller like we showed you in the diagram on those different spots in the TL draw diagram. So you can just cut this end off, cut it at an appropriate length for where it's mounted on your aircraft. If we look at roughly where it's mounted on the aircraft, and this is not the same flight controller as you guys have, but we'll say the GPS mount's going to be up here, and the wires need to come in, come in, down and around, and they're going to be going down to the flight controller, so, roughly somewhere in here-ish. I would definitely measure this more carefully than I am on camera right now, but make sure you have a good length with enough slack to go down into the flight controller. Additionally, I'd highly recommend you take the wires and you twist them into kind of a bundle, because they're going to be coming from outside the drone to inside the drone, and there is some portion of that that will be kind of exposed. If they're twisted like this, there's less chance of them kind of just splaying apart like this, okay, and then getting chopped up by your propeller. So they're twisted to kind of stay in a bundle, and we can route that bundle, down and around and into the drone, and it will stay nice and tight and snug and not be able to kind of flip out and get caught in the prop as easily. So recommend twisting this before you measure, because the measurement will change once you twist the wires. Okay. So let's zoom back out. So let's say you already plugged it in like I did in the video. Silly me, I should have done this in a different order, but you want to get the connector out. Again, use your fingernails and kind of just side to side a little bit, and it will start to come out, and then pull. Now I'm not pulling on the wires, I'm just pulling on the connector. Okay. So real order of operations here would be to get your 3D printed mount. Okay. Take your GPS compass combo here and install it into the mount. So you're going to slip it in there, slide it in there. I'm not going to slide mine all the way in because, like I said, these are kind of hard to get out. You slide it all the way in so the connector is facing the back there. You can kind of see the connector starting to come out. Okay. Once it's installed into the mount, then you go ahead and plug this in the right orientation, and you would then install this on your top plate, twist the wires, take the measurement, and that would be your setup for your GPS. Okay. Hope that makes sense. I apologize for doing it out of order. Got too excited, I guess. That is your GPS with its associated wire and harness. And if you see stuff about compass as well, or a magnetometer, this is a GPS and a compass, or GPS and a magnetometer. That's what we're using here on our build. We're not going to really use the compass or magnetometer with our software, but it's there, and perhaps in the future it'll be something you want to turn on or enable more to use more in your flying or your setup of your quadcopter. All right, that should take care of Duke from the future, and I hope the rest of this video helps you out getting your quad built. Thanks. And for propellers, I wanted to talk to you about that for a second. These motors are called T-mount motors. They do not have a threaded shaft. They just have a smooth motor shaft. Okay, that sticks up there. And our props are designed for those by having these 3 holes. So the center hole is where the shaft goes, and the 2 outer holes are where you put some screws to hold the prop onto the motor. So we have 4 different holes here in the motor. It doesn't really matter. They have 4 of them, so it's easier to line it up, I guess. So we'll put the prop on and try to line up with the holes to make our job a little bit easier. Okay, just like that. Press it all the way down. It should be about flush. And then we bring back our 5 different bags of screws from our motor. Okay, these are the 5 bags of screws that came with each motor. And remember, we use the second to smallest ones to attach the motor to the arm. Okay, now we can pick the middle bag, or middle in size. Okay, or this is the same size as these ones. These are the same size screws. There's different colors. So basically, either of these 2 can be used to attach the props to the motor. Okay, and I think it's just an aesthetic thing, I guess, if you want to pick the silver ones or the black ones. Again, the way I figured out which ones would work best was I took the screw itself, put it on the screwdriver, and put it like this, and said, okay, coming down from the top of the prop here, check that focus, come on. And if they come down from the top of the prop, it should go through the entire prop and go into the motor a little bit, but not too far. And this is a great length. Okay, I think these are M2 by 8s, I think. Anyways, you get that lined up with the hole in the motor. You just screw it in. No, it's not lined up yet. There we go, maybe right there. Feel around for the screw holes a little bit sometimes, get it aligned. There we go. Okay, nice and snug. Goes in just like that, and you put the other screw in there, of course, and do that the same thing for all 4 motors. Okay. This is the one area where you don't use Loctite. If you use Loctite on prop screws or prop nuts, the Loctite will eat away at the plastic the props are made out of and cause the props to basically disintegrate over time. So we don't use Loctite on these. We just check these screws for our pre-flight and things like that. Make sure they're tight and ready to go so they don't come off when we're flying, of course. And that's how you install your propellers. Okay. So that should take care of the physical assembly of your aircraft. And you don't need to put the propellers on until you're all the way ready to fly. I just wanted to show you how in this video. You'll need to do some software configuration to make sure the propellers are going the right direction and stuff way before you ever put them on. So don't worry about that yet, but now you know how to put them on. The rest of the assembly should be covered in Ryan's frame assembly video, so you kind of go back and forth between his video and my video a little bit, I guess. But that should be fine, and that will give you your FPV drone. If you have any questions, please feel free to reach out and ask. Of course, I may have missed something in here or may have misspoke. I hope I didn't, but I think we got everything covered. Let me know if you have any questions, and happy building.